Hello again, method students. In this section, 16D, we're going to be looking at normal distribution questions, but this time in the context of solving problems. So I guess looking at questions where we actually have a context for our variable rather than just being told what the mean and standard deviation is. It might be a variable that actually represents something. For example, IQ scores, heights of people in a population, that sort of thing. But the same skills from the previous section where we're using our calculator and our bell curve sketches to help us out will still apply here. So let's get stuck into some examples. Example 1 says the time taken to complete a logical reasoning test is normally distributed with a mean of 55 seconds and a standard deviation of 8 seconds. And then we've got a series of questions to answer here. So the question hasn't specifically defined it. So let's just say that we're going to let x equal the time taken to complete the test. Time taken to complete this test. And we know that x is a normally distributed variable with a mean of 55 and standard deviation of 8. So we've got mean of 55, standard deviation of 8. Find the probability that a randomly chosen person will take less than 50 seconds to complete this task. Okay, so this is essentially saying we want the probability that x is going to be less than 50. Again, not essential, but definitely a good idea to sketch some sort of bell curve, even if it's a bad one. Mine's a bit too pointy there, but that's okay. So we've got a mean of 55. All right. Now the probability that a randomly chosen person will take less than 50 seconds could be written as PR x is less than 50. And one of the nice things about this sketch is you can go, okay, well straight away I'm going to mark on 50 somewhere here, and I know that that's below the mean. So when I go to work out this probability, I'm really working out this percentage of the distribution, and that should be less than a half, right? Because 50 is below the mean. Okay, but to get the answer, we're going to be using norm CDF on our calculator. And so as a bit of a reminder, because hopefully you've seen the last video and worked through 16C, we're using interactive, distribution, continuous, and then norm CDF. Now it's 50 seconds or less, or sorry, it was less than 50 seconds. So what that means is it's negative infinity as our lower limit, 50 as our upper. Standard deviation was 8, I think. Yep, 8. And the mean was 55. All right, so we get 0.2659. And this is a poorly written question. Sorry, I do this a lot, I know. This one didn't tell us the decimal places to round to, so let's just say 2, because that's what the next question says. So it was 0.2658, so it would round to 0.27 if we went to 2 decimal places. And that was using, on the CAS, so this is just a note, that was, not inverse norm, sorry, norm CDF, negative infinity, 58, 55. Important note here, this sort of calculator speak, if you like, this calculator text isn't sufficient working out, but in most cases, these sorts of questions will only be worth 1 mark because it's understood that you're just going to be using your calculator to get this value, okay? I've just made that note there just so that referring back to it, you can remember where that answer came from. Okay, part B, only the fastest 10% of people will complete the test in t seconds or less. Find the value of t correct to 2 decimal places. All right, so if we, again, just do a quick little thumbnail sketch of our bell curve. Remember this x-axis, that's representing our variable x, which is the amount of time. So t seconds or less means we've got some value along the x-axis where we're looking for a proportion that's below that. Our mean is still 55. But if it's only 10% of people who are below this time, well, this value of t is going to be somewhere to the left of the mean, right? Because essentially what we're saying is wherever this value is, there's 10% of the distribution below it, okay? So this is a case where we can use inverse norm because it's one of these questions where we actually know the probability or the proportion and we're trying to find the x-axis value. And so that's going to be interactive, distribution, inverse, and then inverse norm CDF. So from our little sketch, the tail setting's left because the probability is to the left of a particular value, or the proportion is to the left of that value. So it's 0.1. The standard deviation was 8, and the mean was 55. And so our time value is 44.747, which is 0.75 when we round it to 2 decimal places. So 44 t equals 44.75 seconds. Right, and in the context of the bell curve sketch, that certainly seems to be a realistic looking answer. Okay, because we were expecting a value below the mean, and given that it's only 10%, we were expecting it to be, a reasonable distance below the mean as well. Okay, if 5 people who completed this test are selected randomly, find the probability that exactly 3 of them took less than 50 seconds to do so. All right, so what that's saying is we're just going to pick 5 people randomly who have done the test already, and we want to know the probability that 3 of them took less than 50 seconds to do so. So there's a couple of things going on here. First thing is we're actually now thinking of a variable that is binomial, and that's because we're going to have 5 trials. All right, we're choosing 5 people at random out of all the people who completed this test. The probability of any particular person taking less than 50 seconds to finish the test, well, that was actually what we discovered in part A. It's 0.27. And because each person, what we've said in part A is that any particular person will have this probability. So each time we pick a person at random, that person always has the same probability that they took less than 50 seconds. And so we can say, well, this is now a binomial variable. So the probability that, well, we won't use x actually because x is already another variable. So let's just say we'll let, we're going to let y equal a number of people who took less than 50 seconds excuse my messy handwriting here. And so the probability that y is equal to 3 will just equal, now depending on whether you needed to show working or not, you could use the binomial formula here. So we want we've got 5 trials, we want 3 successes. So it's 0.27 is our probability of success, and we want 3 successes, times 1 minus 0.27, which would be 0.73 to the power of 5 minus 3, because really we want 2 failures. We want 3 successes, 2 failures. So that would be the working step if you needed to show it. But if you remember back to our binomial questions from chapter 14, if we've got our calculator available, which we will most of the time, then it's going to be interactive, distribution, discrete, and then binomial PDF, because in this case we wanted exactly 3 successes. So the x value is 3, that's how many successes. Number of trials is 5. Probability of success is 0.27. And so the probability that we'll get 3 people out of 5 who have taken less than 50 seconds is equal to 0. Now again, no, bad example on my part. I didn't tell you what to round to. So let's go to 3 decimal places this time, 0.105. So that's a really common trick in an extended response question, where at some point somewhere, you'll actually the question will change into a binomial question. So even though this is a normal distribution question, part C has kind of flipped it around into a binomial question, because we've now kind of repeated this selection of people. And so you've got that sense of repeated trials with a fixed probability. So it's jumped into a binomial question, even though it didn't start out that way. All right, in part D, it says people who take 1 minute or less to complete the task are judged to have passed the test. Find the probability that a randomly chosen person who passed the test will have taken less than 50 seconds to complete the task. So let's read this one carefully. First thing to understand is this is no longer binomial, because this one we're just talking about choosing one person again. We're not choosing 5 people or something like that. But what we do know about this randomly chosen person is that they passed the test. So it's a person who passed the test. Now, what that means is we know that this person took 1 minute or less, because if they passed the test, it means they had to have taken 1 minute or less. So this question's saying, find the probability that they will have taken less than 50 seconds if we know they passed the test. So even though it doesn't have that phrase given that, and we have to read it really carefully, this is actually a conditional probability question. It's saying, find the probability that X is less than 50, given that X is less than 60. In other words, find the probability that they took less than 50 seconds if we know they took less than 60 seconds. And then remember, with conditional probability, best thing to do, write the formula. So it's the probability of both over the probability of the second thing. All right, the probability on the bottom is always the probability of the condition that we know has occurred. And then we kind of go from here. Now, if it's got to be less than 50 and less than 60, well, the intersection of less than 50 and less than 60 is just less than 50. Over the probability that X is less than 60. Okay, and we can get both of those probabilities using norm CDF. We actually already have the probability that it's less than 50. That was the first thing we calculated. So we could actually do something like this. We can go get the fraction template there. Here's my calculation that gives me the probability that we're less than 50, and that's the thing that had to go on top. On the bottom, I just want the probability that's less than 60. So I'm actually going to do this. I'm going to copy the whole thing. Oops, not the whole fraction. Maybe I'll get it from the top there. But all I'm going to change here is that upper limit. I'm going to change that to 60. So it's just a bit of a shortcut for getting the two numbers. And then that'll give me my probability straight away. Okay, so I get 0.36237, so equals 0.36237. And again, I forgot to write how many decimal places to round to. I'm not having a good go of this example, so let's go to 3 decimal places. 0.362, correct to 2 decimal places. Okay, so a good extended response question to have a look at there, because it sort of started out as a more typical calculated probability, then use inverse norm CDF. But in part C, we got to practice one that became a binomial question, and then in part D, one that became a conditional probability question. And that's a really common trick that examiners will throw at you in these extended response questions. What we might do is I'll stop this video here and then make a separate one for the rest of 16D, because they're pretty long examples, these ones, but that gives you a bit of a taste of what to expect in these worded extended response questions.